Hi, my name is David Wild and I'm the Chief Scientific Officer for Data2Discovery. I'm going to be giving the 5-minute introduction to what we do and why we do it. So in drug discovery data we have a big problem, but an even bigger opportunity. Pretty much every pharmaceutical company has built up a high-value collection of proprietary data, which is usually stored in relational database tables with various mappings between the tables. You can see this on the left. This facilitates searching of internal data or export of tables, for instance, to allow building of predictive models. But the data remains siloed and it's difficult to make mappings between the tables without pretty unmanageable schema. Then in the last decade there's been built up this huge rich store of datasets in the public domain, but these datasets are also siloed with no established way to link them to each other or to link the proprietary and the public data together in a way which facilitates finding associations and making predictions that go across these data silos. So why hasn't this problem been solved? Well, there are many reasons, including the tight mapping of data to data structure in relational databases, making it very difficult to make mappings between different sources of data. Also, the tying of tools and particular data sets together, data vendors not working together. But most of all is the fact that until recently there really hasn't been a practicable technology for flexibly integrating and mapping different data sets. However, this has now changed. In the last few years we've been able to practically apply semantic technologies to this problem. Data2Discovery scientists were the first to demonstrate how diverse public datasets pertaining to drugs, compounds, genes, pathways, diseases and side effects could be properly integrated using semantic technologies, and the power of searching this integrated data. So we now have strong initiatives like OpenFacts based on this. However, most of the work in this area has been concerned with integrating the data and making it searchable. But what about finding important connections in the data? Finding hidden associations, being able to make predictions that go across data silos. This is where Data2Discovery comes in. So Data2Discovery scientists made the first comprehensive integrated semantic repository of public data for drug discovery. It's called Chem2Bio2RDF, and this showed how we can ask important integrated questions of the data that cross data silos, like what pathways will troglitazone affect? So this work has had a high impact. The original journal article now has 87 citations. It's been used in many different applications. But even more important, data discovery researchers have developed advanced technologies that enable making predictions and finding associations across data sources possible. For instance, our semantic link association prediction, or SLAP technologies, can find hidden associations between drugs and targets based on statistical analyses of networks and data paths that cross many different data sets and data types. Even better, these associations are interpretable, as the networks of significant relationships between nodes have real scientific meaning. So what you see here is a subnetwork of highly significant relationships, in this case between the drug troglitazone and a target called PXR. We can also use these technologies to make predictive profiles of drugs and targets. One project we're working on in association with the Indiana CTSI is using our technologies to actually create a map of hidden molecular connections of type 2 diabetes. And here we're profiling compounds and targets with endpoints like disease states to make supported predictions of impact on the disease of pathways, targets, compounds and so on not currently associated with the disease. We're even able to build drug repurposing maps for the disease. You can see one that's in development on the right. We've already identified, for instance, deep target-based associations of the thiazolidine class of drugs that relate diabetes and cardiovascular disease together. We're also working with a large pharmaceutical company to apply SLAP technologies in drug toxicity, showing how we can make predictions of adverse drug events based on many different kinds of data. We're showing how we can go across data boundaries, be they proprietary and public, or domain boundaries such as between drug and toxicity datasets, and allow understanding of the processes that lead to adverse drug events. So the important point here is we can flexibly include new domains and sources. We can add in proprietary data with public data in a secure server, and we can add new domain data for specialized application. We're already showing how this can have an impact in diabetes and drug toxicity, but there are many other potential applications like DMPK, competitive intelligence, patient data, and so on. So that's the 5-minute what we do and why we do it. To find out more, please go to our website at d2discovery.com, or you can email me directly at david@d2discovery.com. Thank you for listening.